welcome back to our podcast. The things might look a little bit different. We're a tiny little bit other place, different room, and we have a new guest, and well, it's me again speaking English instead of, well, Norwegian, which is the most of our podcasts are in. And today we have a special guest from Germany, Nicolai. So, Nicolai, I guess should introduce Nicolai first. So we meet quite often at different conferences where, well, both of us speak about different topics around Java. And you also do have occasional release some videos about Java and stuff like that on YouTube. You wrote recently a book about Java module system as well, right?
The Java module system. With Manning, yeah.
Yeah, so I guess we should have... Is there anything else you want to say about yourself before we get started?
I tend to describe myself as doing all the things.
Yeah.
Just like, so it takes a long time until something gets done, right? So I do stuff on Medium and newsletter, and the only place where you can meet me where I actually reply pretty quickly is on Twitter, specifically if you say something bad about the module system, then I'll be there. And then I travel around, as I said, to conferences and also occasionally give in-house trainings. So that's why I'm at the moment. I do all the things, but all of them in my own pace, which is not a fast pace.
Yeah, but that's cool. I mean, this is really, really cool. So as most of you probably would have guessed by now, we'll be talking about, surprise, surprise, Java, right?
Like literally.
And we did have a few months back, few releases of this podcast back. We had a talk with Sander.
Sander here.
Oh yes, we did.
Don't get his book.
He's joking.
No, I'm not joking. No, Sander's great. Like if he told you about the module system, then you're all set in that regard, I would say.
Yeah. So then maybe we should talk about some other features. Well, I mean, some of them will be touching up to what we talked about earlier, but we should still probably, give a bit of an overview. So what do you think we should talk about?
So, I mean, one thing we talk about what modules or new features or whatever, it still goes a little weird for a lot of the community because most of the people are still on Java 8.
Yeah.
Looking at 9 or other releases and wondering like, do I want to do that? When do I want to do that? So that kind of stuff. So I would say, so I always poll people wherever I am, when I give a talk, I always ask people, how many of you are running Java 5, 6, 7? Mm-hmm. 4, I don't know.
Yeah, sure.
I usually ask below 8.
Below 8, yeah.
I ask for 8, and then I ask for everything newer than 8, which usually means 11 at this point in time.
Yeah.
And so it's really interesting. So first of all, basically everybody's on 8, and 90% is on 8, and that really doesn't really change a whole lot. But the rest of the people in the beginning, when I first started asking this, like 2 years ago, basically, 2 years ago. Well, yeah, around the time that Java 9 came out. Mm-hmm. So after Java 9 came out, like 1 or 2 people were on 9 and everybody else was still on 8 or earlier. But these other 10 people, right, they slowly move from 7 to... So it's not the same people, obviously, but in the beginning, most of them, of the rest that is not on 8, was below 8. And by now, actually, a majority of the people are later than 8. So we still have like this huge peak of like 90% of the people being on Java 8.
Yeah.
But now we have like 2 or 3% on below and a couple more above. And I think, that's not really representative, right? Because at community meetings or at conferences, you usually meet people who are a little bit more interested in the community, a little bit tend to be a little bit more ahead of the curve, maybe.
Right.
So I don't think that's representative of the entire community, but it still shows that there's a shift towards the newer versions.
I think the numbers that we were looking, we did look into that when we talked with Sander, and we did a bit of kind of research a little bit before that, and I think we ended up with a number of around 80%, 80% being on Java 8, which kind of makes sense. It's very close to what you're saying, right? Like the unofficial polls at the conference, kind of raising up the hands and stuff like that. So it's, that makes sense. But then the thing is that usually I also get questions about is that, okay, well, I'm on 8.
Yeah.
I'm kind of semi up to date, not really, but what people kind of would think they are. And what now? Yeah. What do I do?
Yeah. So I think the first thing to note is that in general 8 is a great release, right? It contains lambdas and streams. That's a fun programming model. It's a productive programming model. It's a fast release in the sense that releases like 9 and 10 took a little bit of a slowdown when it came to boot times. So 8 is in general a good release to be on. That said, unless you pay someone, you don't get updates anymore, right?
Right.
And it's the first thing that you should notice. Like for a while, I mean, there are reasons to be on 8 and there are reasons to be on, let's just skip 9 and 10 to be on 11. So there are reasons for both. But licensing is no longer a reason.
Yeah.
At this point, the licensing for Java 8 and the licensing for Java 11 looks exactly the same.
Yes.
You don't get free support from Oracle. You do get free support from Red Hat if you are an OpenJDK. And then you can choose to either use free support from other people, like you can use Amazon Corretto or Liberica JDK from Bellsoft, or I think Alibaba has their own, I think it's working well. So there are tons of releases out there that you can use. We can maybe come back to that later, what their support model is. But anyway, or you can pay people, right? You can pay Azul, IBM, Red Hat, Oracle. And really, that is the same now on 8 and on 11. So the license is no longer a reason to stay on 8.
Yeah, and there are two things that kind of worth mentioning. One is that if you are on 8 or later or earlier, you won't get any bug fixes or any patches, even security patches, right? So this is...
Well, if you're Oracle JDK 8 and don't pay Oracle, then no.
Yeah, exactly. But so as long as you're not paying... Yes, that's true.
But then also the OpenJDK 8 gets updates from Red Hat, right?
Yes,
so
yes.
if you switch to OpenJDK 8, then you're safe.
Yeah, so that's the point. So if you're on JDK for more... I just kind of want to underline that so people are kind of a bit more aware of that. So as long as you're on the kind of the regular JDK, or what used to be the kind of regular Oracle JDK 8, and you're not paying anyone, you will not get any patches, period.
Since January, so that's like...
So no security patches, yeah, it's been quite a few months now, right?
Is it January 19? Yeah, it was January 2019.
Yes,
that's like 8 months already.
Oh, yeah. So that's one thing, right?
Yeah.
And then the other thing, the reason we're kind of gracefully jumping over Java 10 and stuff like that is probably since not that many people stayed on that. They're either kind of stayed on 9 or 11, and that has probably something to do with more... Or 8, or 8, 9, and 11, I would guess. I mean, people... No, not really?
No,
Don't you think?
I mean, there's no reason to...
No, I know,
don't
that's true.
If you're on 10, then you shouldn't be on 9 either.
That's true. I was like thinking more, in my kind of feeling was that, okay, people kind of migrated to 9 because of the modules and stuff and kind of stayed there, but maybe not. They probably jumped.
It's pretty clear. Like people went to 9, they knew what they were doing in the sense of they knew that the 9 is just a short-term release basically, and then you have to go from there.
Yeah, so then LTE release is probably worth mentioning, right?
Yeah, so I think that's also important to make from a technical perspective. From a technical perspective, 9, 10, 11, of course, have different feature sets, 12 and 13, but that said, they're all the same quality. Well, I think they're high quality. You could say that they all have bugs when they come out, but like which software doesn't. But the point stands, 9, 11, and 12, all these 3 releases went through the exact same quality assurance, and all the other ones as well. I just named these 3 to say 11 in the middle, being long-term release, is nothing special. It's really important, I think, to separate what does the licensing do, what does the model, what does the licensing, what does the support do, and what is the technical aspect of it. And the technical aspect is all of these have the same quality, and then the licensing / support is then the question. Well, that's I think what we're mostly talking about 11. I think at this point they're only really, let's just say everybody's on one of 4 things. They're either before 8, they are on 8, and I think on 220 I'm just going to make that the same thing. They're before 11. And then they're either on 11 or you are on the recent release. And the reason to be on 11 is they say, look, this is too much work. I don't want to update every 6 months, and there are certain insecurities there. We can talk about that as well, maybe. But the gist is, to me, yes, there are reasons not to move from 11 to 12 or 13, but I think they are not as overwhelming as you would think. I think it still makes sense for a lot of projects to just take the jump every couple of months. And so either you stay on 11 because you don't want to do that, and then you stay on 11 basically until you can go to 17 at some point, or you go with every new release. Right.
And so long-term releases is one thing, right? Is that you will get support for longer than the 6 months that the new version comes out, and then you will have also, but then I still think it's like the reason why I kind of was hanging up on 9 is that it has this new, one of the biggest, main, most anticipated whatever features that it was bringing to the table was this the module system, right? That got pushed back and back and back for quite a few times, and then finally it was kind of ready to impress and amaze the world, right? So, and you did write a book about the module system as well. We did talk quite a bit about module system with Sander, but is there anything, if you have to mention like one thing and you have to like talk about one thing, what would that be?
Yeah, so in general, I think the module system is, like, it's a complicated thing to add to a 20-year-old ecosystem, and that made it much more complex than it conceptually is. The module system is just a jar with some meta information, a name, dependencies, and an API. Really, at the core, the module system is really simple.
Exactly.
And then most of the complexity comes from fitting it into a 20-year-old ecosystem where people kind of expect everything just work, but then also they want to move into modules. So when I said, I had to laugh when I said most anticipated, because I really think that there's so many people, like just now I got a tweet a couple of minutes ago from somebody who said, like, look, I just don't want to have modules at all. How can I just deactivate? Doesn't the compiler have a flag to just turn off the entire module thing? It doesn't, by the way, but you can just remove the module info Java. If I somehow get that out of the files to compile, then the compiler goes back to the normal mode. I'm not that camp. I think the module.
And you call it normal mode.
Damn it. Okay. Start over? So the thing is here, I think that the module system does provide value. The migration can be a little bit painful. Migration is going to Java 9 or later. That can be painful, mostly because of the module system. And then modularizing is mostly just work, but most of that work, I think, benefits the overall structure of the system. But you asked about the one feature. And we have a company where I do a lot of work for at Dizzy in Karlsruhe. We have an old project, which is like, it's almost 20 years old as well, right? It's 1.5 million lines of code. It has 400 whatever Maven modules. It runs on Java 11. And we're going to start modularizing it tomorrow. And we're doing that for municipalities and federal states, right? So basically, except that we don't have banks as customers, we basically have all the bad ingredients that you need to stay on Java 4 for the rest of your life. But we don't. And if we can...
That's German,
If we can move forward to Java 9 and then 11, then I think pretty much everybody can if they just put in a little bit of work. The point is, we want to now turn into modules. And why do we turn to modules? And this is one thing that I think is, like, it's actually one of the flagship features of the module system. It's strong encapsulation, but people just kind of like nod along. Okay, I get that, right? You can hide stuff in your jar that is public within your jar, but not visible outside of your jar. And everybody's like, okay, I get it. That's a nice thing. I think like just going over that feature like that is greatly underappreciating what that will provide in the long run. I mean, look, we live and breathe with private and package visible and public. Everybody knows how to use them and when to use them, and everybody knows to keep it as encapsulated, as least visible as possible. And strong encapsulation adds such an important layer in between, where particularly if you have a project that is split across several jars, where you finally have the chance to say in code, I implement this feature. I had these two interfaces, which I would consider public API that everybody can use, and then I have all this other crap that I wrote to make it work, right? It's not crap, of course, it's stellar, clean code and awesome. But at the same time, everybody knows like I write certain parts of the code to just be in service to somebody else and not to be used by everybody. And we often have that problem that somebody writes a feature and then like 2 years down the line, somebody extends some other feature that might seem unrelated, but they realize, oh, wait a minute, I have kind of like a similar use case. Can I use the same code? Because, don't repeat yourself and stuff. And then it turns out, if you use code that somebody wrote for a specific use case and didn't polish to be a public and stable API, and you start using that for a slightly different use case, you're just one more use case away from this turning into a mess.
And then you have to make it backover compatible and stuff like that.
So this is like even within a big system, like within a big application, not even talking about the open source community or that, just having a simple application, just a single application that is split across modules. The fact that you can now say in code, this is supposed to be external supported published API, but the rest is encapsulated, and you will not be able to use it until you add an export to the module for Java. That is amazing. We're so looking forward to that, because that also means you can have a hawk's eye on the module descriptor during declaration. Module for Java is a declaration. You should have like a hawk's eye on that and really pay attention to that during code reviews or during pair programming, whatever way wherever you look at code before it goes into your repository and stays there forever, you need to just wrap up after a long programming session. A close look at the module descriptor, module declaration is worth so much, and then specifically the exports, because you can then say like, look, you exported these 2 packages over there. Are you sure that these are polished? Did you look at them? And I think that will be a big boon to maintainability of larger software systems, but then also to basically everybody who works in the open source community.
It's a very good point, because then it makes you do some kind of action in an explicit manner. So saying like, yes, I actually do want to make that thing available.
Yeah.
I mean, obviously there will be someone that will just like make everything available and just like would just add it. But like most, of course, right? Of course, yeah, right. But then just a general rule, I think it's a good idea. Then you're actually doing a kind of a specific action to make it available, which is a good thing, right?
Yeah, and it's an action that's reasonably observable, because you could say, well, you did that in the past because you have imports, right? Imports give you essentially the same information, but it's not information, it's just data, because it's too much. Like, I know no code reviewer who really looks at imports. Imports are just noise, right? Whenever I do a code review, I just scroll past the imports immediately, because like they're just too many to reasonably process and look at. And that's the thing, right? It's the same information basically, well, it's on the other end, right? It's on the importing, but on the exporting side. But still, you could say, if I use an API that I was not supposed to use, I had a bunch of imports there, but nobody checks those. And then you cannot expect everybody or anybody to really look during a code review to check every of the 10 classes that I added for all the 10 imports that I have. So what you usually do is ignore those. And that's the thing, right? So not only you have to make this action, but you actually have to make it in a way that is easy to observe, easy to give feedback on, to refine, and to have a look at. And also, it's easy to comment on, by the way. Like, I'm a fan of putting in comments, particularly when it comes to why something is the way it is. I think we're not doing a good job on that. Maybe when I come back, I do a rant on the comments.
Do that.
So the thing is, I think we should put in more comments that explain why something is the way it is. And the module declaration is a great place to do that. You can put on, maybe you not only export, but maybe you have a qualified export, which is a little bit of a could be considered a code smell. So maybe you want to put a comment. Why is this API not exported to everybody, but just to a specific module? What's the reason for that? Maybe you have a dependency that you want to get rid of. So that's a great way to place, like, look, I require that module, but I actually do want to get rid of. I use this service for X or Y or Z. So I think that the module system the module declaration really is a good place to collect information, code information, but also the natural language information about that piece of
the semantics of your kind of But that's a good point. And then I think it's also a good way of like explicitly doing something. Since we're talking about the book, one thing that you kind of, because one thing is actually to know stuff, right? The other one is to be able to explain it to somebody else. And then, well, the kind of a bit of a next level above that probably is to be able to write a book and to put it in more kind of systematic manner and everything. One thing that you got like this kind of aha moment where you were like, oh my God, wow, this makes total sense while writing that book, what would that be? Like anything special that you would like, oh wow, I didn't think of it that way, or I didn't know that it was this way until I dig deep into that.
So that's hard to pin anything, because I think that applies to almost everything I know about the module system. Right? Because when I started, I learned about the module system on the JavaFX mailing list, where somebody said, because JavaFX is very prone to using a lot of internal APIs. If you work with JavaFX, a lot of things are not quite the way you want it, so you use a lot of internal APIs. So that's just normal. It was normal on the JavaFX 8 community. So then somebody showed up on the Jigsaw mailing list, I think in 2015, 14 even, no, 15 I think, and said, hey, look, I have seen this information that all these internal APIs will be gone and will break everything. And I read that in the morning before heading out to work. I was like, nah, dude, like there's no Java doesn't break things. You must have misunderstood something, right? I didn't write that, luckily. I just thought that. So then at work, I had a small spat with a colleague, nothing big, but I went home early and decided, because of one of the first warm days that year, that's what I remember. So I'm like, you know what, I'm just going to get a book and some beer and sit on the balcony and enjoy myself instead of being at work and being in a bad mood. But I didn't get a book. I got the mailing list, then I got the JEPs and the JSRs for the module system.
Yes.
And I read through them, and over a couple of days I realized, holy crap, a lot of things are going to break.
Oh, yeah.
So then I wrote a blog post about all of the things that are going to break. And then I was just curious. I wrote a few more blog posts, and at some point I said, you know what? Why don't I turn this into a book? I was ready to self-publish this when Manning called me, and I said, okay, let's do this together. But by that point in time, I had maybe like 10% of the knowledge that I have about the module system now, and everything, all the other 90%, I learned them over the course of writing this book.
Right.
So really, for JLink is a great example. Before I started writing the chapter on JLink, I just knew the damn name. So then I had to sit down and spend like a couple of days or a week just like figuring out how it works and where it breaks, and that is a lot of fun. Like I have fun playing with these things like that, and I would love to apply them to real life projects, but that's always way harder because you don't really want to go to work and be like, okay, I need like 5 people and a month to move everything to this early access build of Java 9 and then modularize it, but then I can try JLink, for my book. So even though I'm really looking forward to that, I think at this point most experience with the module system is bound to be theoretical, right? Or based on demo projects or stuff like that. So I'm really looking forward to that. So, but the thing is, I learned about many of the features just that way, and I think on the last pass through the book, like a couple of days earlier, somebody showed up in the Manning forum for the book and was like, "Hey, wait a minute, that paragraph, that's not right, is it?" I read that critique. I was like, "I'm sure it's right, but let me check." And it was actually wrong. I don't recall now, but it was a small detail, but it was still a critical misunderstanding. I fundamentally misunderstood a small detail. I just covered it in the 2 paragraphs, so it was easy to fix it for the book. But that was like, holy crap, like how could that sneak by me? But the thing is, if something is not, like if you have to build your understanding from just the documentation, then you're bound to sometimes misunderstand something, and then you're just one wrong test away from cementing the wrong meaning, right? So
and then you're actually kind of spreading into everybody else then as well, right?
So I mean, everybody's human, right? You're bound to make errors. But ideally, the author of a book knows things better, right? But since I'm very glad that error got caught, and so I think by now there are few errors in there. I hope none, but let's not fool ourselves. There must kid ourselves. There must be some errors in there. And I think once again that's normal.
You mentioned JLink. And that's one thing, and then there is another J something. That's I know. I was just kind of wanted to spare it for like, but okay.
Okay, sorry.
JDeps, it's out there. Spoiler alert, but that's fine. I wanted just like at the end of this session to mention those 2. So JLink and JDeps. Few words about those 2.
So JLink. Technically, the input for JLink has to be all modules, but you can fake your way. You can use tools like Moditech from Gunnar Morling to make things into module, which it actually isn't. But let's assume you have all modules. You can use JLink to then build a runtime image that contains some of those modules. For example, you can say, I only care about JDK modules, but I only need a subset of those. I'm going to use JLink, create a Java runtime image, which just contains the stuff that I need for my backend, just maybe some XML and some SQL stuff, and no Java desktop.
Right.
Although don't be too eager, because Java Desktop, which is huge, which contains all of AWT and all of Swing, for some crazy circular dependency reasons, it all contains the property API. So if you're using any properties like beans and stuff, then you have to use Java Desktop, which I'm afraid a lot of Java EE projects actually do. But leaving that aside. So the idea is you can cut down the JDK to just what you need and have a smaller runtime image. Which could be nice, for example, if you're using Docker images.
It's very good for microservices, right? And Docker images, and so you don't have to have like, the footprint of the whole thing would be like, 300 something?
No, I think just the JRE is just like 90, and the JDK is I think like 200. But
so it's around 300 something, right? And then that you don't really want to do that. So you want to cut it down, especially when you do microservices and you want to bed with them quick and not
I think the importance of that waned over time, right? I think when the model system was envisioned in 2008, 2009, this was thought for embedded devices where hardware comes at a premium, right? We want to use as few resources as possible. But I think at this time, like almost 10 years later, I think so. It's still an important thing to do, and it's kind of surprising that basically from the other end, like not from the small end, but the large end, suddenly people showed up like, wait a moment, maybe I do want my JDK to be a little bit smaller. But at the same time,
it really makes sense in a way, because you have like, say you do like cloud functions or whatever, and you do it yourself, like on Java and stuff, and that would be quite painful to have like bunch of small functions that all have like, 300 megs of footprint in a memory, right? So you want to have like, say, you have an extreme weird system that has like, 30 of those or 10, and then you have 10 times 300.
Yeah, but at the same time, like remember that since the JDK or the JVM is so amazingly lazy, you only save disk
That's
space,
right,
really,
right.
or maybe network when you push things back and forth. But at runtime, it doesn't really matter whether you have like a million unused classes on the class.
Oh yeah, that's right.
Right. So so what you really gain there is like you making things a little bit faster, right? So it's easier to upload a couple of 100 megabytes and a couple like maybe then 200 more. But once again, I think it's a nice thing to have, but it's not like it's a critical feature.
Yeah.
But what you can also do, and that becomes a little bit more interesting, you can include your own modules in that, right? So you can tell JLink, like, look, this is my main application module. Just do your thing. It will find all the dependencies and all the JDK stuff it needs. And then it takes all of that and puts that into a runtime image.
Yep.
And that's pretty cool because what you have then is an artifact that you can give just anybody, and they don't have to have Java installed. All they need to do is to run the right command, and you can create your own launcher with that. So it's very simple. You just go into the image, then bin / your application name, and there you go. It launches. Nothing else needed. And that's on one hand, that's really nice because particularly if you're deploying software to customers who will run their own JVM, you suddenly don't have to cover like 5 years of JVM releases because you can bring your own. The flip side of that is, you make the JVM kind of part of your own delivery.
So you have to update that as well.
Yeah. So if there's a security hole in that release, then usually you would just tell your customers like, can you please update Java? And if they don't, it's their problem. But now you have to kind of like immediately push a new version. And if you are set up to do that, if you basically have all this automated and the customer will just get an email like, go there, download the new version, it's important, then that's great.
Yeah.
If the deployment process is a little bit more complicated, then maybe you're losing more than you're gaining. But it's just one more option for your tool belt that you can use.
But that's a good thing. So I think we should advise our listeners or people watching the podcast to at least have a look at that. That might be a good idea to see if it fits you. If it's not, just have a look. It might be a good thing. You mentioned just a bit earlier, you mentioned the dependency stuff. So when we're talking about dependencies and stuff, it might be very, very good idea to talk another J something, which is JDeps. And, well, can you say a few words about that as well?
So JDeps, I think the long name is the Java Dependency Analyzer tool. And what it does, it analyzes bytecode and just basically looks for dependencies on other classes, right? So it goes to the .class files and sees, oh, you're referencing that class. And if it finds that class on the class path, it can then analyze that one and so on and so forth. Yeah. So it just basically builds a class-based dependency graph. And then by default, it will basically aggregate that to package dependencies and print those to the terminal, which for a big application is basically unreadable, right? It's huge. Yeah. But you can do all kinds of things with it. First of all, you can actually print the class dependencies, or you can also go one level up and print jar or module dependencies. Yeah. I'm going to come back to that. What you can also do is you can ask it to look for internal APIs that you're using. Yeah. So then you get nice warnings for every internal API that you're using. That's pretty great. I actually built a Maven plugin around that, but then Maven did build an official plugin around that. And one feature that I still don't have, I think, because what we wanted to do is we wanted to break the build when we have to use internal dependencies. Right. Except we kind of knew that these three classes use internal dependencies and internal APIs, and we're not going to get rid of that anytime soon.
So you need to add exceptions.
Right, and they actually JDeps I think takes exceptions in some weird like regular expression kind of form, which is like totally unreadable. Right. So of course I came up with my own DSL because like who wouldn't?
My code, my system is better than yours, kind of thing, right? Yeah.
But the good thing is that you can use it for internal APIs. It will screen from the rooftops if you split packages. Yeah. So if you migrate to Java 9, then a package split between a dependency and the module is a problem. But if you then modularize your own application, you might have splits between modules there. So that's also a problem. And JDeps reports those as well. So there's a bunch of cool things there. But one particular important thing that it does, and I'm making the same joke basically as Sandra. I'm making at a conference when I give this talk about that. It's like we all know this meme of you go to whiteboard and you draw some boxes and arrows and it looks great.
It looks pretty.
Yeah, it looks
clean.
Right? Exactly.
Right.
And then you code and it's still like the code still most likely resembles what you wrote there. But then over time it degenerates. Yeah. But nobody knows, right? Because you don't see it. What you do instead is you take a picture of that whiteboard thing, you upload it to your local Confluence, and then when somebody new arrives, you'll be like, this is our architecture. And they'll be like, wow, that's amazing. It's pretty cool.
That's really, yeah.
And then they look at the code and they're not able to actually align what they see in code to the image because, that image ages, of course.
It's like a garden, right? If you have like really nice garden, it's like everything is pretty and everything. And if you just let it grow wildly, it will just kind of... The roots will be everywhere, and you cannot just like see what is what anymore,
exactly.
Right?
But the thing with I know who was that? I know that was I think it was a guy was it? So I think there was a speaker once who made that comparison that it should not be software architects, it should be more like software gardeners.
Right, it makes sense. Totally makes sense.
The content, just of the person. Anyways, the point is, yeah, you're right. That happens over time. But the interesting thing is, it's like if you're selling tickets, you took a picture of the garden like 5 years ago, and that's what you show at the entrance, right?
Yep.
And when people come, it's like, what the hell is going on here? And the reason for that is that nobody's really interested in taking another picture of a bad garden that sucks when you look at it. And that's the same true with the whiteboard. Who wants to go up to that whiteboard and be like, okay, now we have this dependency and this, and now we have circles here, and we have like these 10 things who all relate to one another. Like that's not a fun thing to do. And it's also like, actually a lot of work, so nobody does that. So what I'm getting at is architecture diagrams are great as input, but they're not really a good representation of what you have, most likely, unless you are sure that they represent reality. And that's what you can use JDeps for. Because JDeps, all this output that I said that it generates, it can generate that in a dot file, and then you can turn that into a graph, and then you can turn that into a PNG. And that's very, very simple, right? On Linux, it's just like basically 2 commands.
Yes.
And you can have that at the end of your build. And that's pretty amazing. You can have, at the end of your build, you put all your code and your dependencies in just one file, in one folder. You tell JDeps to do the entire analysis and generate that PNG, and then you can put that, you have always... If you didn't see one here, don't you have one of these huge screens where the...
Yes, we do. It's a, yeah.
Yeah.
So you can actually show it on a screen, and then if you have something to be ashamed of, then you fix it before the build is done, right?
Maybe, yeah.
Right.
I think that's pretty great that you can actually see an actual representation of your architecture. You can see it evolve over time. Yeah. And you can walk by it and spot things that are weird, right? Because
exactly.
I think most of us think of particular large applications, not just of like 100 jars or modules or whatever, but most of it like in layers, right? You have, or not maybe not in layers, but maybe then in silos. But somehow you have some underlying structure, hopefully,
yes,
and not just 100 random boxes connected to other boxes. Ideally, you have a plan behind that, and you can see how that plan works out in real time. Yeah. You can walk by it and be like, wait a moment, these silos shouldn't know each other. Yeah. So that's pretty good. So I think running JDeps at the end of your build, we would like to do that, but as I said, we have like 400 jars. So the graph is unreadable. Yeah,
then it's a bit hard. Yeah, no, but it's true. It's and it's also a very interesting thing because JLink might be a very good thing for mostly. I would say mostly developers that would be kind of more benefiting of that, and my build is smaller and more nifty and stuff like that. While JDepends will be probably more useful to tech leads and architects and people having a bit of an overview of the system that would know that, okay, hey, how does thing look and what do you do and how do you actually make it work and things like that. So
JDeps is an analyzer, right?
Right. So exactly.
That, and as you say, right, architects usually have more of a use case for that.
And then you can actually, if you go crazy, just realize that you can actually do JDeps as a form of art. You can actually do it on a wall. Now, okay, well, that's another story. I think we should...
JLink had the plugin API. Damn. If JDeps had a plugin API, which was then I said, you should do that. You should come up with a plugin that, I don't know, creates crazy...
Crazy art, like Picasso version of your code or something like that.
I'm afraid that too much code already looks like the Picasso version of itself.
Well, and on that bright note, I think we'll round off this episode, and then there is a big chance that we might come back to again, and then we'll talk a little bit more about some more fun stuff, more new features and new cool things.
Let's do that.
So, thank you for now. Thank you for coming. Thank you for listening.
Yes, thank you.
And, well, see you soon.
See you. Bye.